Rock-forming minerals are the fundamental building blocks of the Earth's crust, constituting the vast majority of rocks we encounter. While thousands of minerals exist, only a few dozen are truly abundant and essential for understanding rock composition and behavior. The silicate mineral group overwhelmingly dominates, making up over 90% of the crust by volume. Their complex crystal structures, based on the silicon-oxygen tetrahedron, dictate key properties and are central to classification. Silicates are the dominant group. Framework silicates are characterized by a three-dimensional network of linked tetrahedra where all oxygen atoms are shared. Feldspars are the single most abundant mineral group in the crust. They are divided into plagioclase feldspar and alkali feldspar. Plagioclase feldspar is a continuous solid solution series from calcium-rich anorthite to sodium-rich albite. It is essential in igneous rocks like basalt, gabbro, granite, and diorite, and in metamorphic rocks. It exhibits striations on cleavage planes. Alkali feldspar is primarily potassium feldspar, including orthoclase, microcline, and sanidine. It is a major constituent of granites, sienites, and granitic gneisses, and is often pinkish or white. Quartz is pure silica, highly stable and resistant to weathering. It is found in granite, rhyolite, sandstone, quartzite, and many metamorphic rocks. It is hard with a hardness of 7, has no cleavage, shows conchoidal fracture, and has a vitreous luster. Sheet silicates have tetrahedra linked into continuous sheets, bonded by weak layers of cations like potassium, magnesium, or aluminum ions or water, leading to perfect basal cleavage. Micas include biotite, which is dark and iron or magnesium-rich, and muscovite, which is light and potassium or aluminum-rich. They are common in granites, pegmatites, schists, and phyllites, and have perfect cleavage into thin, flexible sheets. Clay minerals are fine-grained sheet silicates, such as kaolinite, smectite, and alite, primarily formed by weathering. They are crucial for soil formation and sedimentary rocks like shale and mudstone, and exhibit properties like plasticity and cation exchange capacity. Chain silicates or inosilicates have tetrahedra linked into single or double chains. Pyrozines are single-chain silicates such as augite and diopside. They are common dark minerals in mafic igneous rocks like basalt and gabbro, and in some metamorphic rocks with prismatic cleavage at about 90 degrees. Amphiboles are double-chain silicates such as hornblende. They are common in intermediate igneous rocks like andesite and diorite, and in metamorphic amphibolites, with prismatic cleavage at about 60 or 120 degrees, and are often dark green to black. Independent tetrahedra, or nesosilicates, have tetrahedra isolated by intervening cations. Olivine is a major constituent of ultramafic rocks like peridotite and mafic rocks like basalt. It has an olive green color, glassy luster, and conchoidal fracture, and is highly susceptible to weathering. While less volumetrically significant than silicates, several non-silicates are vital rock formers. Carbonates are based on the carbonate anion. Calcite is the primary mineral in limestone and marble, reacts vigorously with dilute hydrochloric acid, and has excellent rhombohedral cleavage. Dolomite is a major mineral in dolostone, reacts less vigorously with hydrochloric acid only if powdered, and also has rhombohedral cleavage. Sulfates include gypsum, an evaporite mineral forming thick beds. It is soft with a hardness of 2, can be scratched with a fingernail, and has 1 perfect cleavage. Oxides include hematite, an important iron ore mineral common in sedimentary banded iron formations, and as a weathering product with a reddish streak. Magnetite is another major iron ore mineral, strongly magnetic with a black streak. Understanding the major rock-forming minerals, their composition, structure, physical properties, stability, and typical associations provides the essential vocabulary and foundation for interpreting igneous, sedimentary, and metamorphic rocks, deciphering geological processes, and predicting material behavior. This video is part of our free Major Rock-Forming Minerals course for geology students with over 100 subtopics inside. Find the link in the description.